In this video, we're going to learn how to name some alcohols. So IUPAC nomenclature of alcohols. What are some rules to naming alcohols? Well, first we need to find and name the longest continuous parent chain, we call it. And then we need to change the ending of that parent chain from E to OL. So think ethane changes to ethanol. Then we need to number to give that OH or that hydroxyl group the lowest possible number. And then we need to name and number any substituents. So let's go ahead and look at some common alcohols. So in this first example, we see that there is a CH3, CH, CH2, CH2, CH3. So 5 total carbons. 5 total carbons is going to be pent. Now normally we call it pentane with an E ending, but we see that there is an OH on it. So we're going to call it pentanol. Then we need to number in the direction that gives that alcohol the lowest possible number. So if we try left to right, we'll go CH3 and then CH, carbon 2 is where the OH, and then there'll be CH2, carbon 3, CH2, carbon 4, and CH3, carbon 5. So if we number from left to right, we do get a 2 for the OH. If we were to number from right to left, we'd get CH3 carbon 1, CH2 carbon 2, CH2 carbon 3, CH where the OH is would actually be carbon 4, so it'd be higher. So we want to stick with 2 pentanol, because if we numbered from the other direction, it'd actually be 4 pentanol. Okay, let's try another one. Here we have CH3, CH2, CH2, C, CH2. So there are 1, 2, 3, 4, 5 carbons in that main chain, and then it ends in an OH. So again, that's going to be pentanol because there's 5 carbons and an OH. But let's examine this a little carefully, because when we get to CH3, CH2, CH2, C, in this C, there's a CH3 going down and another CH3 going up before the CH2 and then the OH. So there's 2 groups there. So first we need to number to give the alcohol, the OH, the lowest number. If we numbered left to right, it would be on carbon 1, 2, 3, 4, 5. So we don't really want to do that. So let's try from right to left. Then we'll have carbon 1 with the OH, carbon 2 that has the 2 CH3s, one coming up and down. Carbon 3 is CH2, carbon 4 is CH2, and carbon 5 is CH3. So the OH was on our far right, but we decided to number starting at the right. So it would be 1 pentanol. So the 1 tells us where the alcohol is at. The OH is located at carbon 1. So it's really like 1 goes with the all. And then we need to say that there are 2 groups at carbon 2. Each of them are 1 carbon group, so they're each methyl groups. So we'll call it 2,2 and dimethyl because there's 2 of the methyl groups and they're both located at carbon 2. So 2,2-dimethyl 1-pentanol says that there's an alcohol at carbon 1, 2 methyl groups at carbon 2, 5 total carbons in the main carbon chain. Let's look at the next one. We have a hexagon ring, and off of the hexagon is an OH. So we learned that that hexagon ring was just cyclohexane. Well, we're not going to end it in an E anymore. We're going to end it in an ol for the alcohol, or cyclohexanol. And we don't need to number that ring when there's just the 1 group on it. So we just call it cyclohexanol. All right, let's look at the next one. There is an OH on a CH2 and then a CH with 2 different CH3s coming off of it. So only 1 of those CH3s can be in the main chain. So we'll have 1, 2, 3 carbons in that main chain. And then we'll have a methyl group coming off of carbon 2. And it looks like we have an OH coming off of carbon 1, which is already the best numbering we can have. So we numbered in the right direction. So 3 carbons in that main chain is going to be not just propane, but propanol, because we know we have an alcohol at carbon 1. So call it 1-propanol. And then on carbon 2, there was a methyl group. So we'll call it 2-methyl 1-propanol. All right, my handwriting is getting a little squished in there. but 2-methyl-1-propanol. Now, next we have a zigzag chain. We've got an OH, and then it V's up in a V, and then another V, and then a third V, ending in CH3. So each point on this V is a carbon. So really, if we're looking at those V's, it goes OH, and then a carbon on top, and then a carbon coming down, and then a carbon going up, and then a carbon going down, and then a carbon going up, and then it ends in another CH3, or another carbon. So there's the OH is on a total of 1, 2, 3, 4, 5, 6 carbons. They just happen to be in a zigzag. So 6 carbons is going to be hex instead of hexane. We're going to call it hexanol because it started with this alcohol, and that alcohol is on carbon 1. Carbon 1 of the 6 carbon chain. So we've got 1 hexanol. And then we've got our last molecule right here, and it's got CH3, C, CH2, CH3. Now, that second C that we noted has to have more bonded to it. It has an OH going down, and it has a CH3 going up. So there's 4 carbons in the main chain, CH3, C, CH2, CH3. So 4 carbons is going to be bute, but it's not butane anymore. It's butanol. Take off the E and put the OL ending because we caught that there was an alcohol on that second carbon. Now making the alcohol on carbon 2 is going to be way better than having the alcohol on carbon 1, 2, 3 if we numbered from the other direction. So let's keep the alcohol on carbon 2, 1, 2 butanol. And then we also have a methyl on carbon 2. So this will be a 2-methyl. So on carbon 2, there was both an alcohol going down and a methyl going up. So this would be 2-methyl, 2-butanol. So those are some basic different types of molecules that we might have to name that contain alcohols.